Welcome to qnawire.
Hi there. Here we have to calculate the force at which field created by charges 1 and 3 act on charge 2. But prior to do this calculation, we have to find angles and the dimensions in the system. So as we can see from the triangle 1, 2, 3, sides 3, 2 and 3, 1 are the same, which equal to A. So therefore, angle 1 equals to angle 2 and equals to 45 degree, because angle 132 is a right angle. So, and also the distance between points 1 and 2 equals to A multiplied by square root of 2. Now we basically know the parameters which we need for calculation. So first, let's start with the x component which acts on the second charge. But first we have to write down the expression for the total force which acts on charge 2. So it equals to the force with which the first charge acts on charge 2, and the force with which the third charge acts on charge 2. So it means that x projection of this force equals to sum of these two components. So now we have to sketch these forces. First, let's redraw the system. Again, these are our points 1, 3, and 2. And here is the hypotenuse. Let's introduce axes y and x. Yeah, so probably it's wiser to take x to the opposite direction. We'll see it later. So charges 1 and 2 are the same, both negative. Therefore, these two charges will undergo repulsion. So the force F12 is shown here. And charges 3 and 2 are both negative and positive, so they have an opposite sign. Therefore, they will interact with the attraction force. So F3, 2 will be directed to the left. So probably let's change the direction of the x-axis again. But again, it doesn't really matter. Like we can take any direction to the left or to the right. It will affect only the angle. Sorry. Yeah, sorry, I've been experiencing some technical difficulties, but now it's solved. Yeah, as I said, let's direct x to the right. And here it's probably easier to direct y to the bottom, because we see the final force will be directed to the bottom as well. So now we can already sketch the projections of these forces. So F12 will have two projections, which is F12x and F12y. And this angle, let's call it angle 3, equals to angle 1. So angle 3 equals to angle 1 equals to 45 degree, because they are formed by two parallel lines. So this guy is parallel to the x-axis, and this is just a line which intersects both of these angles, both of these parallel lines. So, and as we can also see, F32 doesn't have any projection on the y-axis. So therefore, Fx, which acts on the second charge, equals to F12x minus F32x. So F12x equals to F12 multiplied by cosine of angle 3, which is F12 multiplied by cosine of 45 degree. F12, absolute value of F12 equals to K multiplied by Q1 multiplied by Q2 absolute divided by D12 squared and multiplied by cosine of 45, which is 1 over square root of 2. So the distance between points 1 and 2 is a multiplied by square root of 2. So therefore this guy becomes K multiplied by Q1, Q2 absolute divided by square root of 2 multiplied by 2 multiplied by a square. Okay, and F32x simply equals to K absolute of Q2 multiplied by Q3 divided by the distance between points 2 and 3 squared, which equals to K Q2 Q3 divided by a squared. So therefore Fx equals to K Q1 Q2 divided by square root of 2 multiplied by 2 by a squared minus K multiplied by Q2 Q3 absolute divided by a squared. So now let's simplify this expression. So K divided by a squared multiplied by absolute value of Q2, and it's all multiplied by Q1 absolute minus Q3 absolute. Now let's calculate this number. Oops. This force equals to Fx, which is 9 multiplied by 10 power by 9 newtons meter squared divided by coulomb squared multiplied by Q2, so 6.5 power by negative 9 coulombs divided by 0.00 multiplied by 10 minus 3 squared, and it's all multiplied by yeah, I forgot to divide this guy by 2 square roots of 2, obviously. So it's, yeah, so in the brackets we have 6.5 multiplied by 10 power by negative 9 coulombs over 2 square roots of 2. Two square roots of 2 negative 3.3 multiplied by 10 power by negative 9 coulombs. So now I have to use a calculator to complete this calculation. So it equals to negative 0.00234 newtons, which roughly equals to 2.34 millinewtons. So this is the x component of the force. Oh, sorry, negative, obviously. So the negative sign basically means that the real component will be directed to the left. So to the left. So basically we chose an x to the wrong direction, but again, it doesn't really matter. So now let's calculate Fy. So Fy equals to the sum of y components of each force. So it equals to F12 y plus F32 y. But as we see, this force 32 is perpendicular to the y direction, therefore this guy is 0. So it means that y component equals to F12 y, or F12 multiplied by the cosine of cosine of angle 3. Sorry, not by cosine, by sine. Yeah, multiplied by sine of angle 3, or F12 multiplied by sine of 45 degree, which is F12 over square root of 2. So F12 is a repulsion force, but we've already taken into account the signs. So F12 equals to K Q1 multiplied by Q2, absolute value, because we are calculating an absolute value of the force, divided by square root of 2, and multiplied by square root of 2 multiplied by a all squared. So in other words, it equals to k q1 q2 over 2 square roots of 2 multiplied by a. So now let's do this calculation. Y component of the force equals to 9 multiplied by 10 power by 9 newtons meter squared per coulomb squared multiplied by 6.50 multiplied by 10 power minus 9 coulombs multiplied by the same charge and divided by 2 square roots of 2 multiplied by basically 5 millimeters. So now let's use a calculator to get this number. It equals to the following newtons, or roughly 5.38 millinewtons. So now we've calculated the y component, and now we have to calculate the total force. So again, we have to redraw this geometry, this system, because we'll need it to answer questions C and D. So again, point 1, point 3, point 2. So here let's sketch our forces. So Fx is here, it's directed to the left, and Fy is directed down, and Fy is larger than Fx. So it means that the total force will be directed to the right, to the left bottom corner of the screen, and its value, so the total value of F equals to Fx plus Fy, or if we talk about the absolute value of F, it equals to Fx squared plus Fy squared, all the square root of this sum. So let's calculate it. It equals to square root of, where is this force? 2.34 squared plus 5.38 squared millinewtons, which equals to 5.87 millinewtons. Okay, so this is a total, this is a total force which acts on the second charge. And lastly, we have to calculate the direction. So here, basically, let's for the direction, let's choose this angle alpha, formed by the line connecting point 3 and 2, and the direction of the force. So the direction So how would we find this angle? This angle alpha equals to a tangent of Fy over Fx. Yeah, because tangent of this angle equals to Fy, cotangent, it equals to Fy over Fx. So therefore, it equals to a tangent of 2.502, which is 68.2 degree. So it means that the total force will be directed to the left bottom corner of the screen, and the angle between this direction and the line connecting points 3 and 2 is 68.2 degree. Okay, let's summarize our answer. So the x component is 2.34 millinewtons, and it's directed to the left. Fy equals to 5.38 millinewtons, and it's directed to the bottom. C total force equals to 5.87 millinewtons, and the direction is 68.2 degree, where this alpha is the angle between the distance between points 2 and 3, and the x-axis. So this is a summary of the answer. I hope I helped you. Thank you very much. Bye.